Hello and welcome to How to Econ. Today we will go through the topics of monopolistic competition and oligopoly. I will talk about monopolistic competition first, then oligopoly and game theory afterward. Monopolistic competition involves many firms competing against each other but selling products that are distinctive or differentiated in some way. Examples include stores that sell different styles of clothing, restaurants or grocery stores that sell a variety of food. A firm can try to make its products different from those of its competitors in several ways: physical aspects of the product, location from which it sells the product, intangible aspects of the product, and perceptions of the product. Physical aspects of a product include all the phrases you hear in advertisement: unbreakable bottle, non-stick surface, freezer to microwave, non-shrink, extra spicy, newly redesigned for your comfort, etc. and etc. A firm's location can also create a difference between producers. For example, a gas station located at a heavily traveled intersection can probably sell more gas because more cars drive by that corner. Intangible aspects can differentiate a product too. Some intangible aspects may be promises like a guarantee of satisfaction or money back, a reputation for high quality, services like free delivery or offering a loan to purchase the product. Finally, product differentiation may occur in the minds of buyers. For example, many people could not tell the difference in taste between common varieties of ketchup or mayonnaise if they were blindfolded, but because of past habits and advertising, they have strong preferences for certain brands. Advertising can play a role in shaping these intangible preferences. When products are distinctive, each firm has a mini monopoly on its particular style or flavor or brand name. However, firms producing such products must also compete with other styles and flavors and brand names. The term monopolistic competition captures this mixture of mini monopoly and tough competition. A monopolistically competitive firm perceives a demand for its goods that is an intermediate case between monopoly and competition. This figure offers a reminder that the demand curve that a perfectly competitive firm faces is perfectly elastic or flat, because the perfectly competitive firm can sell any quantity it wishes at the prevailing market price. In contrast, the demand curve as faced by a monopolist is the market demand curve, since a monopolist is the only firm in the market and hence is downward sloping. The demand curve as a monopolistic competitor faces is not flat, but rather downward sloping, which means that the monopolistic competitor can raise its price without losing all of its customers, or lower the price and gain more customers. Since there are substitutes, the demand curve facing a monopolistically competitive firm is more elastic than that of a monopoly, where there are no close substitutes. Now, let's see how a monopolistic competitor chooses price and quantity. The monopolistically competitive firm decides on its profit-maximizing quantity and price in much the same way as a monopolist. First, the firm selects the profit-maximizing quantity to produce. Then, the firm decides what price to charge for that quantity based on its perceived demand curve. As an example of a profit-maximizing monopolistic competitor, consider this La La Land pizza store, which serves pizza with cheese, mushrooms, pineapples, and seafood. Although La La Land Pizza must compete against other pizza businesses and restaurants, it has a differentiated product. The firm's perceived demand curve is downward sloping, with other cost curves shown in this graph. To maximize profits, the La La Land Pizza would choose a quantity where marginal revenue equals marginal cost, or where MR equals MC. Here, it would choose a quantity of 40. When the store has determined its profit-maximizing quantity, it can then look to its perceived demand curve to find out what it can charge for that quantity of output. On the graph, we show this process as a vertical line reaching up through the profit-maximizing quantity until it hits the firm's perceived demand curve. So for La La Land Pizza, it should charge a price of $16 per pizza for a quantity of 40. The store's total revenues are the rectangle with the quantity of 40 on the horizontal axis and the price of $16 on the vertical axis. The firm's total costs are the light shaded rectangle with the same quantity of 40 on the horizontal axis, but the average cost of $14.5 on the vertical axis. Profit are total revenues minus total cost, which is the shaded area above the average cost curve. In this case, profit is $60 because total revenue is $640 and total cost is $580. Although the process by which a monopolistic competitor makes decisions about quantity and price is similar to the way in which a monopolist makes such decisions, two differences are worth remembering. First, both a monopolist and a monopolistic competitor face downward sloping demand curves. The monopolist's perceived demand curve is the market demand curve, while the perceived demand curve for a monopolistic competitor is based on the extent of its product differentiation and how many competitors it faces. Second, a monopolist is surrounded by barriers to entry and need not fear entry, but a monopolistic competitor who earns profits must expect the entry of firms with similar but differentiated products. So in the long run, if one monopolistic competitor earns positive economic profits, other firms will be tempted to enter the market. The entry of other firms into the same general market shifts the demand curve that a monopolistically competitive firm faces. As more firms enter the market, the quantity demanded at a given price for any particular firm will decline, and the firm's perceived demand curve will shift to the left. As a firm's perceived demand curve shifts to the left, its marginal revenue curve will shift to the left too. The shift in marginal revenue will change the profit maximizing quantity that the firm chooses to produce, since marginal revenue will then equal marginal cost at a lower quantity. Figure A on the left shows a situation in which a monopolistic competitor was earning a profit with its original perceived demand curve D0. The intersection of the marginal revenue curve MR0 and marginal cost curve MC occurs at point S, corresponding to quantity Q0, which is associated on the demand curve at point T with price P0. The combination of price P0 and quantity Q0 lies above the average cost curve, which shows that the firm is earning positive economic profits. Positive economic profits attract competing firms to the industry, driving the original firm's demand down to D1. At the new equilibrium with P1 and Q1, the original firm is earning zero economic profits and entry into the industry ceases. Remember that zero economic profit is not equivalent to zero accounting profit. A zero economic profit means the firm's accounting profit is equal to its opportunity cost. In figure B on the right, the opposite occurs. At P0 and Q0, the firm is losing money. If you follow the dotted line above Q0, you can see that average cost is above price. Losses induce firms to leave the industry. When they do, demand for the original firm rises to D1, where once again the firm is earning zero profit. In conclusion, monopolistic competitors can make an economic profit or loss in the short run, but in the long run, entry and exit will drive these firms toward a zero economic profit outcome. However, the zero economic profit outcome in monopolistic competition looks different from zero economic profit outcome in perfect competition in several ways, relating both to efficiency and to variety in the market. The long-term result of entry and exit in a perfectly competitive market is that all firms end up selling at the price level determined by the lowest point on the average cost curve, as an example in the upper graph. This outcome is why perfect competition displays productive efficiency. Goods are produced at the lowest possible average cost. However, in monopolistic competition, the end result of entry and exit is that firms end up with a price that lies on the downward sloping portion of the average cost curve, not at the very bottom of the average cost curve, as an example in the lower graph. Thus, monopolistic competition will not be productively efficient. In a perfectly competitive market, each firm produces at a quantity where price is set equal to marginal cost, both in the short run and long run. This outcome is why perfect competition displays allocative efficiency, the social benefits of additional production as measured by the marginal benefit, which is the same as the price, equal the marginal cost to society of that production. In a monopolistically competitive market, the rule for maximizing profit is to set MR equals MC, and price is higher than marginal revenue, not equal to it because the demand curve is downward sloping. When the price is larger than marginal cost, which is the outcome in a monopolistically competitive market, the benefits to society of providing additional quantity as measured by the price that people are willing to pay exceed the marginal cost to society of producing those units. A monopolistically competitive firm does not produce more, which means that society loses the net benefit of those extra units. This is the same argument we make about monopoly, but in this case, the allocative inefficiency will be smaller. Even though monopolistic competition does not provide productive efficiency or allocative efficiency, it does have benefits of its own. Product differentiation is based on variety and innovation. Most people would prefer to live in an economy with many kinds of clothes, foods, and car styles, not in a world of perfect competition where everyone will always wear blue jeans and white shirts, eat only spaghetti with plain red sauce, and drive an identical model car. Most people would prefer to live in an economy where firms are struggling to figure out ways of attracting customers by methods like friendlier service, free delivery, guarantees of quality, variations on existing products, and a better shopping experience. In monopolistically competitive industries, product differentiation and markup pricing lead naturally to the use of advertising. In general, the more differentiated the products, the more advertising firms buy. Economists disagree about the social value of advertising, though. Some say that it provides useful information to buyers. Informed buyers can more easily find and exploit price differences, and advertising sometimes is considered as a signal of quality. However, the critic says that society is wasting the resources it devotes to advertising. It manipulates people's taste, and advertising creates the perception that products are more differentiated than they really are, allowing higher markups. Now, let's talk about another situation on the competition spectrum. We call it oligopoly. Oligopoly arises when a small number of large firms have all or most of the sales in an industry. Examples of oligopoly include the auto industry, cable television, and commercial air travel. Why do oligopolies exist? Well, a combination of the barriers to entry that create monopolies and the product differentiation that characterize monopolistic competition can create the setting for an oligopoly. If oligopolists compete hard, they may end up acting very much like perfect competitors, driving down costs and leading to zero profits for all. If oligopolists collude with each other, they may effectively act like a monopoly and succeed in pushing up prices and earning consistently high levels of profit. We typically characterize oligopolies by mutual interdependence where various decisions such as output, price, and advertising depend on other firms' decisions. Analyzing the choices of oligopolistic firms about pricing and quantity produced involves considering the pros and cons of competition versus collusion at a given point in time. When oligopoly firms in a certain market decide what quantity to produce and what price to charge, they face a temptation to act as if they were a monopoly. By acting together, oligopolistic firms can hold down industry output, charge a higher price, and divide the profit among themselves. When firms act together in this way to reduce output and keep prices high, it is called collusion. A group of firms that have a formal agreement to collude to produce the monopoly output and sell at a monopoly price is called a cartel. In the United States, as well as many other countries, it is illegal for firms to collude since collusion is anti-competitive behavior, which is a violation of antitrust law. Both the Antitrust Division of the Justice Department and the Federal Trade Commission have responsibilities for preventing collusion in the United States. The problem of enforcement is finding hard evidence of collusion. Cartels are formal agreements to collude. Because cartel agreements provide evidence of collusion, they are rare in the United States. Even when oligopolists recognize that they could benefit as a group by acting like a monopoly, each individual oligopoly faces a private temptation to produce just a slightly higher quantity and earn slightly higher profit, while still counting on the other oligopolists to hold down their production and keep prices high. If at least some oligopolists give in to this temptation and start producing more, then the market price will fall. A small handful of oligopoly firms may end up competing so fiercely that they all find themselves earning zero economic profits, as if they were perfect competitors. Because of the complexity of oligopoly, which is the result of mutual interdependence among firms, there's no single, generally accepted theory of how oligopolies behave, in the same way that we have theories for all the other market structures. Instead, economists use game theory, a branch of mathematics that analyzes situations in which players must make decisions and then receive payoffs based on what other players decide to do. The prisoner's dilemma is a scenario in which the gains from cooperation are larger than the rewards from pursuing self-interest. It applies well to oligopoly. The story behind the prisoner's dilemma goes like this. Two partners in crime are arrested. When they are taken to the police station, they refuse to say anything and are put in separate interrogation rooms. Eventually, a police officer enters the room where prisoner A is being held and says, "You know what? Your partner in the other room is confessing. Your partner is going to get a life prison sentence for just 1 year, and because you are remaining silent, the judge is going to stick you with 8 years in prison. Why don't you get smart? If you confess too, we'll cut your jail time down to 5 years and your partner will get 5 years also." Over in the next room, another police officer is giving exactly the same speech to prisoner B. What the police officers do not say is that if both prisoners remain silent, the evidence against them is not especially strong and the prisoners will end up with only 2 years in jail each. The game theory situation facing the two prisoners is summarized in the table on the screen. To understand the dilemma, first consider the choices from prisoner A's point of view. If A believes that B will confess, then A should confess too, so as to not get stuck with the 8 years in prison. However, if A believes that B will not confess, then A will be tempted to act selfishly and confess, so as to serve only 1 year. The key point is that A has an incentive to confess regardless of what choice B makes. B faces the same set of choices and thus will have an incentive to confess regardless of what choice A makes. To confess is called the dominant strategy. It is a strategy an individual or firm or player will pursue regardless of the other individuals or firms or players' decision. The result is that if prisoners pursue their own self-interest, both are likely to confess and end up doing a total of 10 years of jail time between them. This is a Nash equilibrium. It is named after the mathematician John Nash, who won the Nobel Prize in Economics in 1994. The famous movie A Beautiful Mind is based on the book of the same name about him. A Nash equilibrium is a set of strategies, one for each player, such that no player has incentive to change his or her strategy given what the other players are doing. The name is called a dilemma because if the two prisoners had cooperated by both remaining silent, they would only have had to serve a total of 4 years of jail time between them. If the two prisoners can work out some way of cooperating so that neither one will confess, they will both be better off than if they each follow their own individual self-interest, which in this case leads straight into longer jail terms. Let's take a look at the oligopoly version of the prisoner's dilemma. If each of the oligopolists cooperates in holding down output, then high monopoly profits are possible. Each oligopolist, however, must worry that while it is holding down output, other firms are taking advantage of the high price by raising output and earning higher profits. The table on the screen shows the prisoner's dilemma for a two-firm oligopoly, known as a duopoly. If firms A and B both agree to hold down output, they are acting together as a monopoly and will each earn $1,000 in profits. However, both firms' dominant strategy is to increase output, in which case each will earn $400 in profits. Can the two firms trust each other? Consider the situation of firm A. If A thinks that B will cheat on their agreement and increase output, then A will increase output too, because for A, the profit of $400 when both firms increase output, which is the bottom right-hand choice in the table, is better than a profit of only $200 if A keeps output low and B raises output, the upper right-hand choice in the table. If A thinks that B will cooperate by holding down output, then A may seize the opportunity to earn higher profits by raising output. After all, if B is going to hold down output, then A can earn $1,500 in profit by expanding output, the bottom left-hand choice in the table, compared with only $1,000 by holding down output as well, the upper left-hand choice in the table. Thus, firm A will reason that it makes sense to expand output if B holds down output, and that it also makes sense to expand output if B raises output. Expanding output is the dominant strategy for firm A because firm A will do it regardless of what firm B does, as we just analyzed. Again, B faces a parallel set of decisions that will lead B also to expand output. So expanding output is also the dominant strategy for firm B. The result of this prisoner's dilemma is often that even though A and B could make the highest combined profits by cooperating in producing a lower level of output and acting like a monopolist, the two firms may well end up in a situation where they each increase output and earn only $400 each in profits. Here again is what we call a Nash equilibrium when at least one player or firm has a dominant strategy. We are using firms or players with similar payoffs of their decisions in these examples to make it easy to follow and help you focus on the key concepts of game theory. Please keep in mind that in reality, firms might have different payoffs and dominant strategies. There are many other examples of the prisoner's dilemma. For example, two firms spend millions on TV ads to steal business from each other. Each firm's ad cancels out the effect of the other, and both firms' profits fall by the cost of the ads. Member countries try to act like a cartel, agree to limit oil production to boost prices and profits, but agreements sometimes break down when individual countries renege. In arms race between military superpowers, each country could be better off if both disarm, but each has a dominant strategy of arming. For common resources, all could be better off if everyone conserved common resources, but each person's dominant strategy is overusing the resources. How can parties who find themselves in a prisoner's dilemma situation avoid the undesired outcome and cooperate with each other? The way out of a prisoner's dilemma is to find a way to penalize those who do not cooperate. Perhaps the easiest approach for colluding oligopolists, as you might imagine, would be to sign a contract with each other that they will hold output low and keep prices high. If a group of US companies signed such a contract, however, it would be illegal. Certain international organizations, like the nations that are members of the Organization of Petroleum Exporting Countries (OPEC), have signed international agreements to act like a monopoly, hold out output, and keep prices high so that all of the countries can make high profits from oil exports. Such agreements, however, because they fall in a gray area of international law, are not legally enforceable. Alternatively, oligopolists may choose to act in a way that generates pressure on each firm to stick to its agreed quantity of output. One example of the pressure these firms can exert on one another is the king demand curve, in which competing oligopoly firms commit to match price cuts but not price increases. This graph shows an example of an oligopoly airline who has agreed with the rest of a cartel to provide a quantity of 10,000 seats on the New York to Los Angeles route at a price of $500 per ticket. This choice defines the king in the firm's perceived demand curve. The reason that the firm faces a kink in its demand curve is because of how the other oligopolists react to changes in the firm's price. If the oligopolist decides to produce more and cut its price, the other members of the cartel will immediately match any price cuts, and therefore a lower price brings very little increase in quantity sold. If one firm cuts its price to $300, it will be able to sell only 11,000 seats. However, if the airline seeks to raise prices, the other oligopolists will not raise their prices, and so the firm that raised prices will lose a considerable share of sales. For example, if the firm raises its price to $550 per ticket, its sales drop to $5,000 seats sold. Thus, if oligopolists always match price cuts by other firms in the cartel but do not match price increases, then none of the oligopolists will have a strong incentive to change prices, since the potential gains are minimal. This strategy can work like a silent form of cooperation in which the cartel successfully manages to hold down output, increase price, and share a monopoly level of profits even without any legally enforceable agreement. This is the end of this topic. Thanks for watching and see you in the next video.